Hello, Physical Science. Welcome to live Q&A session number 5. So in this quick little talk, I'm going to go through what's important and some of the questions that I've been receiving. Now, I will stress again that it's really awesome if you guys would post your questions to the live Q&A session, because what ends up happening again is that it allows other students to see your question, and then that way I don't have to send out multiple emails. I can just send out simply one email and address the concern. Now, if it's a private topic, of course, send me an email, and preferably you should send that email by CBC, by lsmith@cbc.edu, because then you don't have to worry about the issue of possibly others being able to see your email in Canvas, because believe it or not, Canvas does have an option where it can reveal all of your messages, and I know you don't want that, and I think that would be not good. Okay, so let me just go over a few things. One of the students asked the question about lab number 3 and how to compute the density of water. So let's go through that right quick. So of course, it's a quick view for our labs for the course. Simply click onto lab number 3 and we bring it up. And of course, this is the buoyancy lab. And let me just say that it actually makes a lot of sense if you go back and you just review the Archimedes Principle TED Talk, because this actually will help you to understand what's the principle and how do you, the same principle that you're applying, for example, in the bathtub is the exact same thing that you're doing with the boat, with the ice cube, etc. So let's go through this. The very first thing that you have to do is you have to figure out the density of water. Well, to figure out the density of water, you're going to need a type of scale. So let me make sure too I bring up the scale that you need to use. There's a very inexpensive one at Walmart. You can definitely get one probably from the Goodwill also. I would not be shocked if there was one at the Goodwill. So it's sometimes called a diet scale or a kitchen scale. Notice there's one here, Mainstay, $4.97. It's a typical scale that you would buy. And so you're going to take this little cup-like device, and you're going to place it on the scale and see how much it weighs. Of course, it's not going to weigh very much at all. You're looking at something like ounces, and if we're talking about grams, very light, okay? So let's suppose, for example, that it was 2 grams. And of course, that's giving it a lot, but let's suppose it was just 2 grams, okay? So if it was 2 grams, and let me bring my whiteboard out so you can kind of get a better idea of what's happening here. So if it was 2 grams, and let's just say that this was the mass of the beaker. It's the beaker alone when you set it on the scale. Now you add the 100 mils of water, okay? And you stuck now the beaker with the water back onto the scale, and let's just say it was 91.2, or so let's just make it easy, 92.0 grams now that the beaker weighed with the water. So how do you figure the density of the water? Well, you know that this was 0, right? Because we didn't have any water in it. And if we know that density equals mass divided by volume, we can easily figure this out. So then you're going to just simply take the large from the small. So 92 minus 2 grams will give us 90 grams. Oops. Okay, so not sure exactly how. We said that was 2. Okay. Oh, I see that it's inserting here. Okay, so you get the point for that. So I'm just going to remove that. Okay, so that'll be 90 grams. Okay. Okay, so now that means that we know how much water we have. That's the volume. We know how many grams is water because we subtracted it from just the empty beaker. So we know how much was actually contributed by the beaker, how much actually is contributed by the water itself, and that's its mass. So now we just simply do the division, which is 90, and that's divided by 100, and that will give us the density of water, okay? And so that's how you solve that problem. stick it into your calculator, voila, it's like magic. Okay, now the same thing happens when you're talking about an ice cube. So now since you know the density of water, you keep working with the density of water now, and you compare everything to the changes that's happening with the ice cube, with the boat, etc. Okay, so if we're not starting, we don't care about the beaker anymore, because the beaker was just the starting point to figure out the density of water. Now we move on and we say, okay, since we know the volume of water, since we know the volume of water and we know the mass of the water, then once we have that particular information, all we have to do is just now stick the ice cube into the water and notice the rise in the water, subtract that from the original volume that we know water that we started off with, 100 mils, also weighing the ice cube, and we do the same thing with the boat, okay? And in that way, you can go a roundabout way of figuring out the density of any object, okay? That was the whole point of this exercise. Okay. Now the next question that I had, and make sure I delete this whole thing because we don't need this anymore. There we go. And we can get rid of the whiteboard. And we want to go back to share our screen. Okay. So again, you probably can pick some of these up from the Goodwill. And I'll show you what the box looks like. It's a small little box. It's not very big at all. Okay, and you can see it can go up to a 907 grams. Very, actually, it's also a useful little scale too, in case you want to use it, or you can sell it to some students for the next class. Okay. Okay. Now the next thing that students ask questions about were about the lens kits. I sent an email about a week ago at least, probably longer. In fact, 2 weeks ago, I sent an email asking students if they could afford to buy the kit. I did receive emails stating that students were not interested or they could not buy the kit because they were having struggles in some cases of just affording the materials that was for the current labs. So my decision then was to don't buy the kit. And I sent another email out, and the email was about at least a week old. And it was also to state to the students that you do not have to purchase the lens kit because the lens kit would cost an additional at least $13 to $16. And some students just don't have that money to spend on the lens kit that they probably won't use again after this course. So this was the decision that we made. I received very little input in it from the students who wanted to do it. So the only students that actually did say something was students who were struggling financially and could not pay for this additional kit. So the call was pretty easy because no one else came up to make any suggestion, etc. So if you purchase the kit, your best solution is then to send the kit back and get a refund, because in your emails, it has already told you in announcements not to purchase the kit. Okay. So now let's move on. We have an exam coming up, okay? And that exam is over 3 chapters. So I haven't received any emails from students asking about how to solve problems. So I'm going to assume that you guys know how to solve all the problems from chapter 1, chapter 2, and chapter 3, because that's what you're going to be tested over. And if you have questions about that, then this is the time you guys should have posted questions in the live Q&A, or at least been active in this live Q&A session, or at least send an email so that way I can kind of get an idea of where you are. Again, you will be able to use this useful information. Now, the useful information, I will say that you don't need the temperatures. That's the temperature formula, so that's towards the bottom of here of the scale, of this useful information, because we'll be working with this particular chapter next week. So all of this you will not be using. However, you will need this British to metric and metric to British conversion table. You will need all of these formulas to figure out problems, and there's a number of problems on the exam. So if you feel comfortable with working with the problems and exercises that's in the textbook, in the self-check as well, then you should be good to go. But we will see at the end of exam 1, and hopefully you guys do very well. Okay. I don't really have any more business. All I can say is that exam number 3 is due by Sunday, and so is your exam. It is due Sunday, 11:59. If you are late taking the exam will automatically submit, and you will have a 0 for this test. Please do not miss taking this test, because if you had to take the test earlier, you would have already emailed me and we could have made arrangements for you to take the test earlier. There will be absolutely no excuses of why you cannot take the test, or why you could not take the test between Saturday and Sunday. The test is open for 2 days. You are aware of the time that the test is open. Again, if you do not take the test by 11:59 on Sunday, I will simply assign a 0. There will not be any excuses that will be accepted unless you were in the ER, okay? So please do not ask for any extension, because you will not get it. Okay. So again, use the self-checks. Also, please go through all of the recordings. If you don't want to go through the recordings, that's fine. Just simply click onto the PowerPoints or the PDFs, and you should be fine with that as well. Okay, I'm going to sign off, post this. If you have any questions, let me know.